Hey everyone, welcome all of you. In this video, I'm going to explain a simple question about simplex method. So let's get started. As you can see here, this is our linear problem. And for applying simplex method in a problem, we should convert it in a standard form. As you can see in this question, our constraints are smaller than equality constraints. So we should, while we are converting it standard form, we should add a slack variable for each of them. And I added already, and all the variables are of course greater than or equal to 0. So after that, at the beginning solution, as you can see, we will choose select variables as a basic variables, and the others can change. And our basic variables value, as you can see, s1 equal to 15, s2 equal to 7, s3 equal to 12, and our z value is already 0. So let's first create a simplex table about with this value. So as you can see, our while creating our simplex table, we will look first max objective function, and we will get of course x1 and x2 as a minus, and our z is 1. And these are the right hand side values, and this is s1 constraint, and this is s2, and this is s3. While we look this simplex table, this is not optimal. If you want to say a simplex table to optimal, this objective function uh, is all value in this objective function should be greater than or equal to 0. I mean non-negative. So we should convert it to optimal table. First, we will determine entering variable. In that case, when we look x1 and x2 value, x1 is minimum, so we will choose that row as this column as a pivot column, and we determine as entering variable as x1. After that, we will determine a leaving variable, and for determining that, we should apply ratio test. We will divide x1 pivot column by right hand side value, and we will get new value, as you can see, 15, 7, and 6. After that, we will get again the minimum value, and s3 row is equal to 6, and this is the minimum. And this intersection point is our pivot element. Why this is important? Because while we are creating a new simplex table, this pivot element will be equal to 1, and the others will be 0. So let's go on. While we are doing as you can see, our simplex tables basis changed. S3 is leaving and x1 is entering, and we did x1 intersection point is 1, and the others 0 by these steps. Applying these steps, you can remember algebra course. After that, again we will check this table is optimal or not. As you can see, this is not optimal because x eq values is smaller than 0. It is negative. So we will apply the same steps again. We will choose x3, x2 as a entering value, and for determining leaving value, we will again apply the ratio test with x2 column, and we will get this value. After that, we choose again the minimum value, which is 2, and this is the s2 constraint row. So our entering variable is x2, and leaving variable is s2. Again, I created a new table by applying these methods again from algebraic course. And after that, I'm again checking if this table is optimal or not. As you can see, there is no negative value in this part, and this table is optimal. And after that, this is our result, and our optimal value is already 19. And x1, x2, and s1s are our basis variables, and these are non-bases. So that's all for today. Thanks for listening.